Okay, so in this video we're going to cover something called the quadratic formula. The quadratic formula looks scary and looks horrible. Seems like it's going to be difficult to use, but it actually makes your life much easier. The quadratic formula tells you x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. And this is a great equation that lets you find what factors you have inside of a polynomial. And the great thing about the quadratic formula is that if there's an answer to your polynomial, it will always work. You'll always get an answer. You'll always get the right answer if you can actually get an answer. And it depends on a quadratic formula, on a polynomial equation of the form a times x squared plus b times x plus c being equal to 0. And all these respective variables, this a that goes with your squared term, this b that goes with your x term, and this c that's a number that's all by itself. They all plug in to this quadratic formula to let you solve for x, which is the variable that you're interested in finding. Like I said, this quadratic formula will always work. So let's see how this actually works. So let's do an example. Let's look at the example 6 times k squared minus 6 times k minus 12 is equal to 0. Now I can, right underneath this, I can write down the general equation for a polynomial. General equation, we know, is ax squared plus bx plus c is equal to 0. And I recommend doing this until you get very comfortable with what these equations actually mean. And then I can directly see what everything is. I can see with my little x squared, my a, point a nice little arrow up to give me my 6. With my x term in this case is k, so my b is going to be equal to this negative 6, and then my c term I can see is going to be equal to this 12. So I can explicitly write out what those all are. My a is equal to 6, my b is equal to negative 6, and that's important to notice that this general form has ax squared plus this bx, and in our problem that we're solving we have a negative here, so we need to put that negative into that b term. And then we have c is equal to negative 12. Again, we notice that the general format has this as a positive c. Since I have a negative 12 here, then that negative comes along with my constant, and I have a c equal to negative 12. And now I can just solve this. I don't have to factor anything. I don't have to really even think. This is just plugging in and chugging along. So I know x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And I can just plug and chug my numbers in. X is equal to negative b. B is equal to negative 6. So I'm going to plug in a negative 6 for my b. Plus or minus the square root of b squared. B is again negative 6. And I need to square that. Minus 4 times my a. My a is equal to 6. So 4 times 6 times c. What is my c? My c is equal to negative 12 times negative 12. All divided by 2 times my a, which we already found was equal to 6. So now it's just algebra. It's just multiplying these numbers out, adding things together. So I've just rewritten the exact same thing that we had on our previous slide, and we're going to multiply these things out. So negative times negative 6 is going to give me x is equal to 6. And then I have plus or minus the square root of 6 squared. And this is a negative 6 squared. When I do negative 6 times negative 6, I get 36. Minus this 4 times this 6 times this negative 12, which is all going to combine together when I multiply them all together to give me negative 288. That's all going to be divided by 2 times a. 2 times 6 is 12. Then I can keep solving this out. I'm doing this step by step. You can do it all in one fell swoop if you want. X equals 6 plus or minus the square root of 36 minus this negative. So negative, subtracting a negative gives me a positive. So I end up with square root of 324. And when I take, and that's divided by that 12. So I do x is equal to 6 plus or minus the square root of 324, which is going to be equal to 18, all divided by 12. And at this point, I can split this up into two different answers. Because as we remember, quadratic formulas should have two different answers. So I have one where x is equal to 6 plus 18 divided by 12, and I have the alternative where I can use the negative sign, where I can have x is equal to 6 minus 18 divided by 12. If I solve out this top one, 6 plus 18 is 24, 24 divided by 12, and I get x is equal to 2. But I also have another solution where I have x equals 6 minus 18. That's the second one down here. X equals 6 minus 18 divided by 12. So I have x is equal to 6 minus 18, which is negative 12, divided by 12. So I find x is equal to negative 1. And I found my two solutions for the quadratic formula. And this will work every single time. So let's try one more example. Let's say I want to know the factors for the following polynomial. I want to know x squared minus 121 equals 0. Well, what's going to be the answer? Well, I need to write this in the format of ax squared plus bx plus c is equal to 0. If I look, I can see my x squared. I can draw a nice little arrow to find out what my a is. My a is this implied 1 that is out front, in front of that x squared. So a is equal to 1. If I look for b, b goes along with this x term. I don't see any x terms. So that means that my b is equal to 0. And then finally, the number that's sitting around all by itself, this c is equal to, it looks to me like it's negative 121. So I can use my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I plug in my numbers. I just plug and chug these guys right over here. Negative b is equal to 0, so I have 0 plus or minus the square root of 0 squared minus 4 times a, which is equal to 1, and c, which is equal to negative 121. All divided by 2 times a, where a is equal to 1. So I have x is equal to 0 plus or minus the square root of all of this stuff multiplied together. When I do all of this stuff multiplied together, I get a 0 squared plus 4 times 1 times 121 is equal to 484. And I divide all of that by 2, because 2 times 1 gives me a 2 in my denominator. So now I have x is equal to 0 plus or minus the square root of 484, which is 22, all divided by 2. And here I separate out into two different answers, where I assume x is equal to 0 plus 22 over 2, and x is equal to 0 minus 22 over 2. So I find x is equal to 11, or x is equal to negative 11, which I got just by taking 22 divided by 2 over here, and negative 22 divided by 2 to get the negative 11. And that's how you solve problems with the quadratic equation, which will always work.